Let us see more sums on range of K using Routh-Hurwitz criterion. Third one, S cube, S square. 1, 3K, K plus 2, 4. So what you will get, S power 1 is 3K multiplied by K plus 2 minus 4 upon 3K upon 3K. S power 0, you will get a 4. So what are the conditions? So for a stable system, the first column elements must be greater than 0. For no sign change, the first element is positive. Therefore, all the remaining elements also must be positive. Therefore, 3K must be greater than 0. Therefore, K must be greater than 0. K must be greater than 0. First condition. This is the first condition. Second condition we can get from here. 3K square plus 6K minus 4 should be greater than 0. 3K square plus 6K minus 4 should be greater than 0. Or we can say that K square plus 2K minus 4 by 3. 4 by 3, 1.33 greater than 0. The roots are K equal to minus 2.527 and minus 0.527. Therefore, we can factorize this as K plus 2.527 and K minus 0.527 should be greater than 0. So the K must be, what should be the value of K? K should be greater than 0.527. Greater than 0.527. One condition is K must be greater than 0. The second condition is K must be greater than 0.527. So if it satisfies, automatically this will be satisfied. Therefore, we can ignore this condition. You can consider this alone. K must be greater than 0.527. K must be greater than 0.527 alone can be considered. Because automatically this will be satisfied. Automatically this will be satisfied. So the second condition is satisfied, then automatically first condition will be satisfied. Therefore, if K equal to 0.527, then what you will get is, you will get sustained oscillation. Because rho of 0 you will get. If K equal to 0.527 means, you will get a rho of 0. S power 1 rho becomes 0. If S equal to 0.527, if you substitute here, this becomes 0. This becomes 0. It means rho of 0. Therefore, this becomes auxiliary equation. So we can find the roots on the j omega axis by using that. Are you able to follow? If S power 1 rho becomes 0 means, for what value this becomes 0? The factorized value is 0.527. Therefore, when k equal to 0.527, this becomes 0. That is s power 1 row becomes 0. It is important point you consider. S power 1 row becomes 0. Only one element is there in s power 1. Therefore, row of zeros. Therefore, s square row becomes auxiliary equation. Auxiliary equation means we can find poles on the j omega axis. Therefore, substitute k value in the s square row. Consider s square row. Take s square row and substitute k value. 3 times 0.527. 527 plus 4 s square plus 4 equal to 0. If you substitute that, what you will get is s square equal to minus 4 upon 3.527. If you substitute this, if you find s, that is j omega equal to s equal to plus or minus j 1.59. So the poles on the j omega axis. What is S plane? This is S plane. This is S plane. This is sigma. This is j omega. Omega means what? Frequency. Omega means frequency. Frequency is 1.59. Therefore, the frequency of oscillation, the question it is asked, the question, find the frequency of oscillation. Determine the value of k so that the system is marginally stable and find the frequency of oscillation. Determine the value of k so that the system is marginally stable. The first sum, 11.36 we got. In the second sum, for none of the values, the system is stable. For the third sum, when k is equal to 0.527, it exhibits sustained oscillation. Poles are on the j omega axis. What is the frequency of oscillation? 1.59 radians per second. 1.59 radians per second. We can find the frequency of oscillation. Do you understand this?